Hi, I'm Zach Wisner-Gross, and today I'm going to be sharing with you one of our monthly challenges. This one is related to Pi Day, and it's a really, really inefficient way to approximate pi by tossing needles. So here you're going to toss needles on this first screen. Some of them will cross these lines. The spacing of the lines is the same as the length of the needle. Some of them cross, some of them don't. The ones that cross are highlighted in red, the ones that don't are in blue. And students will look at the ratio between these two. On the next screen, they'll estimate the probability of one of these needles crossing one of the lines based on their empirical results. Then they can play around and change the angle, the angular orientation, and the vertical height of this abstract needle and see when it crosses the line. They can capture different places where it does so, try to get a sense of where in this crazy space the crossings happen and where they don't. On the next screen, they'll see the answer here. So all in the red regions, the needle's crossing the lines. In the blue region, it's not. The ratio of these areas, it involves calculus. We need to get into that. So on the next screen, the shapes will morph into something a little friendlier, rectangles for students to compute that ratio. Then they'll see that the answer turns out to be 2 over pi, or they'll have figured that out for themselves and see how that matches up with their empirical results. The really, really cool part of all this activity, and what I mentioned at the beginning, using it to approximate pi, this ratio of crossings over total throws is approximately equal to 2 over pi. So you can rearrange it to say that pi is approximately 2 times the number of throws over the number of crossings. So at the end, you can get your whole class to throw a lot of needles. They can just mash this throw button over here. And lo and behold, 2t, 2 times the number of throws over the number of crossings, looks a little low, a little high, it varies. But over time, that will converge very, very, very slowly to pi. So let's see how I did here. I did 56, 57, 60 throws. Ooh, exactly. Oh, 61 throws, 62 throws. And on the last screen here, I can see I'm only 3.7% off. There's a version of this activity that everyone can join as well. This is what the results of that look like. So far, something like 3,000 or 4,000 needles, virtual needles, have been thrown. And it looks like the approximation is 3.103 after tossing of almost 3,900 needles. So join that activity as well, the challenge, and throw tons and tons of needles over time. Together, we can all work really, really hard to come up with a really inefficient but awesome approximation for pi. Thank you.